Hello, class. I want to cover section 2.3, quadratic functions and their zeros. So what we're going to learn how to do is find the zeros of a quadratic function by factoring, find the zeros of a quadratic function using the square root, that should be a t, square root method, find the zeros of a quadratic function by completing the square, and find the zeros of a quadratic function using the quadratic formula. So with all these methods, so there's 1, 2, 3, 4, we're really just trying to do the same thing. We're just trying to solve a quadratic equation, but there's 4 different ways that we can use. Now, this method, not all quadratic equations can be factored, and not all quadratic equations are really set up to use the square root property. But you could always use completing the square, and you can always use the quadratic formula. Can always use. Sorry, can already use or always use. Okay, and this one also, we can always use this. Okay. So this is what a quadratic function looks like. F of x equal ax squared plus bx plus c. And what really makes it a quadratic equation is the 2 right here. So this is what we call standard form for a quadratic equation. And a, b, and c have to be real numbers with a not equal to 0. Because if a was equal to 0, then it'd be a linear equation. The domain of a quadratic function consists of all real numbers. So that means from negative infinity to infinity. Now, a quadratic equation, and we're going to have to talk about that because we're going to be talking about the zeros of a quadratic function. So a quadratic equation looks like this. This is equivalent to this form, basically, where a, b, and c are real numbers and a doesn't equal 0. And then a quadratic equation written in this form, where we've got it in the form that where we've got it, really the exponent is in decreasing order because the exponent here is a 1. The exponent here is actually a 0. So it's written in standard form. If the leading exponent is a 2, then it's quadratic, and that's also sometimes called second degree. You know, we said that linear was first degree, and a quadratic can be called a second degree equation. We usually call it a quadratic. If you've got a third degree equation, usually we just say third degree, or if it's higher than 2, we usually just say third degree, fourth degree. Sometimes we might say for three degree, we might say cubic. 4 methods of solving quadratic equations, and we've already mentioned this: factoring the square root method, completing the square, and the quadratic formula. So let's talk about some examples of quadratic functions and some examples of functions that are not quadratic. Okay, so quadratic might look like this. It might have, all 3 terms, a squared term, a term to the first degree, and a constant. Or it might only have 2 terms. It might not have an x term. It may just have the +1. Or it might only have 2 terms and it doesn't have the constant term. So it could look like any of these 3. And it, I'm just using these coefficients as an example. Oh, and one other thing, I didn't even mention this. It could also look like this. Really doesn't have to have more than 1 term. That's a quadratic function as well. Not quadratic. would be functions like this. If we've got f of x equal 1 over x, we're going to talk about that coming up. That's what's called a rational equation, or f of x equals 1 over x. Oh, that is 1 over x. I mean, the square root of x. That's a rational equation. This is what's called a radical equation. And of course, you know, linear is not quadratic. Or this is also not quadratic. And, you know, anytime the exponent of the leading term, when it's written in standard form, if it's not 2, then it's not a quadratic equation. Okay, let's see what's on the next page. So this says find the zeros of a quadratic function by factoring. So that's the first method that we're going to look at. So when a quadratic is written in this form, it may be possible to factor the expression on the left side as a product of two first-degree polynomials. Then the zero product property may be used to set each factor equal to 0, and the resulting linear equation may be solved to obtain the exact solutions of the quadratic equation. And we've seen some of this already when we were talking about x-intercepts. So we're going to be using this property, which says if the product of two numbers is 0, then at least one of the factors is 0. That is, if AB equals 0, then A equals 0 or B equals 0, or both. Okay. So the steps to solve a quadratic equation by factoring, first thing you want to do is get it set equal to 0. So you want it in standard form, and you generally want your leading coefficient to be positive. It's easier to factor that way. Factor the polynomial on the side opposite 0, then set each factor to 0 and solve each resulting equation. Okay, so we also want to review a little bit of factoring. So we talked about this at the beginning or sometime during the semester before this. So these are the steps. So or the rules, if you have 4 or more terms and you've already combined your like terms, so you should always combine like terms at first, okay? And you should also get it set equal to 0. Well, at least for this. So I won't say that right there. So if you have 4 more terms, you're going to try factoring by grouping. If you have 3 terms, and if you write it in this form, it could be that it's a perfect square trinomial, and they factor. So this is if it's in the form a square at the end, plus twice the product of the things that are squared in the middle, and it could have a plus sign here or a minus sign here. This will be plus. The way it factors is into a plus b squared and a minus b squared in this one. And you can see that it works out. Like if you go a plus b times a plus b, you're going to get a squared plus 2ab plus b squared. Now, otherwise, if you've got 3 terms, they call it the trial and error method, but I don't really use trial and error, at least not when I'm working with a quadratic that doesn't have 1 as a leading coefficient. I use what's called the grouping method for factoring a trinomial, and I'll look at that in a minute. Now, if it only has 2 terms, so then it's called a binomial. If it's a difference of squares, so that means you've got a square and a square and you've got a minus in the middle, then this is how it factors, a plus b times a minus b. If it's a sum of cubes, you have to remember this formula. So at some point I had to memorize this, and I just memorized it. You know, I'm sure it's not that hard to derive, but I wouldn't worry about deriving it. I would just remember the formula. Now, it's easy to remember. In this one, it has the a plus b in the parenthesis. So this is a plus sign right here. And in this one, it has an a minus b. And then in the plus side, it has the minus sign right there. And with the minus sign, it has the plus sign right here. So it's just a matter of minus and plus signs and where they go. So anyways, this is just a formula. Now a sum of squares, so a squared plus b squared, cannot be factored with real numbers. So, you know, if you've got something like this, x squared plus 4 equals 0, you can't factor that with real zeros. And if you have x squared minus 4, you can go x minus 2 times x plus 2 equals 0. And then we can go x equal 2, x equal minus 2. Because what we're doing right here is using the zero product property. Now, I'll talk about that some more, but if it's got a plus sign, it just doesn't factor into real numbers. Okay. Let's see what's coming next. Too many papers. Too many papers here. Okay, so let's look. So what I want to do is I want to find the zeros of the quadratic function by factoring, and then what are the x-intercepts. So we're going to try, what we're going to do, since we're trying to find the zeros, for the zeros, that's the x-intercepts. And to find the x-intercepts, we set y equal to 0. Well, y is h of x, or whatever the function's name is, h of x, f of x, g of x, whatever. So we set y equal to 0, so that means 0 goes right here. Now, we do have a binomial, but one thing to always remember, and this is the first step. I didn't put it there, but it should be the first step. Well, we set it equal to 0 as the first step. And then factor out the GCF. What GCF stands for is the greatest common factor. So we do have a common factor here. We do not have a difference of squares. So this is not a difference of squares. Why is that? Well, it's because this x is not squared, or this is not squared. Okay, we don't have this variable is not squared. Now, x squared is a square and 9 is a square, but this is the problem. So it's not a difference of squares, but it does have the GCF equal to x. Because you look at this, both of these terms have a factor of x. So I'm going to factor an x out. Now, then I have two factors. Equals 0. So that's like a times b equals 0. So we use the 0 property. It's the 0 property principle or something. We set each of these factors equal to 0. So we get one of the zeros right there. It is actually 0. And then this gives us x equal 9 and that's the other one. Okay, so it asks, find the zeros of the quadratic function by factoring. What are the x-intercepts? Well, I can answer that. What's that? The zeros are x equals 0, x equal 9, and they are the x-intercepts. So whatever you get for the zeros, as long as they are real numbers, then that's what we have for the x-intercept. Now look at this function versus this function. What is different? And that didn't come out real well, but it says, and I'm going to set it equal to 0. It says x squared minus 9. This is a difference of squares. So the way it's going to factor, so this is a difference of squares. So you have to remember that the way that factors, if you've got a squared minus b squared, it factors into a minus b times a plus b. So we can factor it like that. We can go 0 equals x minus 3 times x plus 3. You see, in this case, your a, looking at this and this, your a is x and your b is 3, because 9 is 3 squared. And then we're going to use the 0 property. So we set x minus 3 equal to 0, and we set x plus 3 equal to 0. We get x equal 3, and we get x equal negative 3. So zeros are x equal plus or minus 3. Let's say it like that. And that's the x-intercepts. Same thing. Okay, let's look at this next one. And we've got, we've got h of x equal 2x squared minus 50. Okay. Well, this is not a difference of squares when we look at it. Because 2 is not a perfect square and 50 is not a perfect square. But is there a common factor? And if so, what is the greatest common factor? So you want to factor out the greatest number that you can. So the greatest common factor, and I'm going to just kind of put a line here so we don't get this confused. The greatest common factor is equal to 2. So what, and first we're going to set it equal to 0. And then we're going to factor a 2 out. Well, when we do that, look what we have. We have a difference of squares here. Now, what you can do is you can go ahead and divide by 2. And 0 divided by 2 is just 0. Why didn't I do that up here? Why didn't I just divide by x? You can't, because there's always a possibility of x being 0. In this case, it is 0. So you can't divide by a variable unless you know for sure it's not 0. And that would probably have to be given if that were the case. But when you're factoring, you're not going to be dividing by by x ever. But we can divide 0 by a constant, and 0 divided by 2 is just going to be 0. So then we get 0 equals x squared minus 25. And you know that's x squared minus 5 squared. So it is a difference of squares. So it's going to factor like this. And that's going to give us x equal 5, or x equal plus or minus 5. And so those are the zeros and the x-intercepts. Okay, now this might look tempting to just move the 12, or like if you set it equal to 0, which is the first thing we do. And what some people do, and I can see why they might think that, is they move the 12, they add 12 to both sides. And then it's already factored here. They say, well, x is 12 or x minus 4 is 12. That's not true. Just because you have a product set equal to 12, it doesn't mean that one of them is 12. You know, you could have 3 times 4, that's equal to 12. It doesn't mean that each of these is equal to 12. So that's not what you want to do. So we have to get in standard form. And remember that standard form is a squared plus b squared. I mean, I'm sorry, this is not right. It's a times x squared plus bx plus c equals 0. Okay, so what we're going to have to do is we're going to have to multiply. So actually, first, factoring is undoing multiplication. But in this example, we have to multiply first and then factor. So we're going to have x squared minus 4x minus 12. And now it is in standard form. So we've got it in standard form. Now, this is a trinomial. It is not a perfect square trinomial. I know that because this is not a perfect square. So it's a type of trinomial that, they say factor by trial and error. I know I've seen some students that have learned in high school to make some kind of little box, which is really more useful when you have a trinomial that doesn't have 1 as a leading coefficient. Those are harder, and we'll look at those, but those are harder to factor. But with this one, really all you need is 2 numbers whose product equal minus 12 and whose sum equals minus 4. So the product is equal to, why did I write 2 there? I just don't know why. I'll say something and then not write the same thing. There's something wrong with my brain. So anyways, we want the product to be minus 12 and the sum to be whatever the coefficient is in the middle. So we need to think of 2 numbers who have a product of negative 12 and a sum of negative 4. Now, if you want to, and if you need to, you can go off and you can just write it out. Like, just a little bit. For instance, you could go, well, 12, and you could figure out the factors of 12. It's 12 times 1, or 12 times 1. It's 6 times 2. It's 4 times 3. And then it's 3 times 4. And you can stop there because you've got all of them. Now, this is a negative 12. So if it's a negative 12, one of these is going to have to be negative. So you want it. So, you think about it. You could make this negative, this negative, this negative, and this negative, or that's a minus 12. Or you could make the 12 positive and the 1 negative. Or this is supposed to be a 6 times 2. You could make the 6 positive and the 2 negative. Or you could make the 3 positive and make the 4 negative. Or make the 3, that's the same thing, so let's do that. Now, so all of these are going to give you products of that are equal to negative 12, but which one gives you a sum that is equal to negative 4? Not this one. That sum would be 11. 6 and minus 2 Could that give me a -4? Well, what if I make the 6 negative? -6 plus 2 would give me -4. So that's what I want to use. And then I'm just going to go right out. The parenthesis is going to have an X, and then it's going to have an X here. I know that when the coefficient is 1. And then it's going to have these numbers, and I was going to use a -6 and a +2. Because that would give me x squared plus 2x minus 6x minus 12. So then we set each factor equal to 0. We get x equals 6, and we get x equal -2. Okay, so those are the zeros. Okay. Let's look at our next example. See everything. Here we go. So we want to find the zeros again. We're still finding the zeros. So the first thing we're going to do is set the y equal to 0. And then the next thing you want to do, and you want to always ask yourself, what is the greatest common factor? Well, it's 1. I mean, there's the only number that goes into 3, the only integer that goes into 3, 5, and 2 is 1. So we can't factor any other number out, and there's no point in factoring out of 1. So the way I do it is called the grouping method. And I think they teach this in the book too. And this just will always work, but you have to remember how to do it. So, you do need to remember how to do it. So the way you do it is you go 3 times 3 times 2. So you're multiplying the first coefficient times the last coefficient, and that'll give you a 6. So you want to find 2 numbers whose product equals 6 and whose sum equals whatever the middle coefficient is. And in this case, that is a 5. Okay, so we could go through and we could write out the factors of 6 if you want to. But, there's not that many factors of 6. So, and this is a +6, and this is a +5. So what we need to use is a +3 and +2. Because 3 times 2 is 6, and 3 plus 2 is 5. Sometimes people be tempted to use 6 and -1, but that won't work. All right, so now what do? Well, this is what you've got to remember. We're going to rewrite it as using those numbers 3 and 2. So I'm going to rewrite it, and it doesn't matter which I write first, the 3x or the 2x. But what we've done is we've created 4 terms. So we've now got 4 terms. That is equivalent to this, because those 2 add up to be 5x. Then we factor by grouping. So we group the first 2 terms together. Be careful if there's a minus sign there, because then you'd have to change the sign here once you wrote the parentheses. But there isn't, so I'll just put the parentheses around the 2x plus 2. So I group these 2 together, and I group those 2 together. Now, basically what we've done here is we've created 4 terms so that we can factor by grouping. Then the way you do this is you factor the greatest common factor out of this group. So the greatest common factor is a 3x. And what's left will be an x plus 1. Then you factor the greatest common factor out of this group, and that's a 2. Now, if this is going to work, these have to be identical. And if they're not, you probably made some kind of mistake. So this has to be, these have to be the same. What's in this parenthesis has to be the same as what's in this parenthesis. Then what you do is you actually factor this common factor. See, when you're multiplying things together, they're called factors. So we're multiplying a 3 times an x plus 1, 2 times an x plus 1. The x plus 1 is a common factor. So of each of these terms. So I'm going to factor it out. And then what I have left is a 3x plus 2. So it's kind of like we're pulling that 2x plus 1 out in the front. All right, not the 2x plus 1, but the x plus 1. And then this is what's left. And you always want to write the plus sign that's left, because what's left is this, this, and this. And then we just use the 0 product. So I'm kind of running out of space here. We set each equal to 0. And we get x equal -1. And we get x equal -2/3. And those are our zeros. Okay, class, the next thing that we're going to learn is to find the zeros of a quadratic function using the square root property. So to solve this equation, you've got x squared equals some number. And p is a non-negative number, because if it's negative, then you're not going to get a real number. So if you think about it, if you were to subtract the p from both sides and set it equal to 0, and you consider this as a difference of squares, because p is the square root of p times the square root of p. So in this case, we go x minus the square root of p times x plus the square root of p, set it equal to 0. So we'll get x equal to the square root of p, or x equal minus square root of p. So really what we're saying is x equal plus or minus the square root of p. Well, instead of going through all this, we use the square root property. And this is the square root property. So if you've got x squared equal p, and p is either greater than or equal to 0, then you can just go x is equal to square root of p, or x is equal to minus square root of p, or you can also say x equal plus or minus the square root of p. Okay, so we're going to solve some using the square root property. So here we go. So the first thing I'm going to do is set it equal to 0. Now, you don't always use the square root property, because, you know, if you had an x term in here, it wouldn't work to just directly use the square root property. You'd have to complete the square first, and we're going to see that in a minute. But if you've got just the square term, the x or whatever square term, and just the constant term, then we can use the square root property. But what we want to do, we want to get, we're going to add 18 to both sides. We want, in this case, we want not set equal to 0. We want the constant over on the other side. And then 18 is positive. So then what we're going to do is we're going to go plus or minus the square root of 18. And that's going to be equal to x. So the big thing to remember is, and this is what, you know, a lot of times I see students forget, is you have to go plus or minus. Sometimes I see and they just go square root of 18. But that's not true, because there's two numbers that square to give you 18. There's negative square root of 18, because a negative square root of 18 times a negative square root of 18. It'll be a plus, and the square root of 18 times square root of 18 is just going to be 18. Okay, so now this can simplify. And I'm not sure if my math lab makes you simplify it, and probably does, but, and I'm just going to write it in this order now. We can, if you can divide out a perfect square from this number 18, then you can simplify it. Now, 18 is divisible by a perfect square number. It's divisible by 9, which is a perfect square. So I'm going to write it like this. And then what I'm going to do, you can break it apart into the square root of 9 times the square root of 2. But then that's going to give me x equal plus or minus 3 times the square root of 2. You can check it. Check them one at a time. So like if you do the positive 3 times the square root of 2, and you square that, you get 9 times 2, which is 18. And the same thing if it's a negative. Okay, so square root property, you isolate the x squared, get the number on the other side. If the number is positive, then we'll use the square root property. Honestly, you may at some point deal with non-real numbers if you're going on in math, for sure you will. You actually can use the square root property even if this is a negative number, but it becomes an imaginary number. And we don't teach that for some reason in this class anymore. I don't know, we used to. But anyways, I forgot what I was going to say. But anyways, yeah. So if it's in this form, then you get the x squared on one side and you get the and you get the number on the other side. And then you use the square root property. It just looks sideways to me, but I'm not sure it is. Okay, so let's look at the next problem. This is actually in the form or first let's get it set equal to 0, then it'll be in the form. Right. Okay, let's set it equal to 0. It's in the form where we can use the square root property. You could multiply this out and get a trinomial and then factor it. That would be more work, but you certainly can do that. But if I tell you to use the square root property on a test, I mean for you to use the square root property. So then what I can do is add 75 to both sides. And see, this is in the form with the number equal to something squared. So, you know, what variable do I want to use? Whatever. Let's just call it u squared. That would make sense. So we can go ahead and we can use the square root property. And then what I need to do is add 2 to both sides. And that's going to look like this. It's going to look like 2 plus or minus the square root of 75 equals 3x. Okay, then what I'm going to do is I'm going to go, well, first of all, I think what I'll do is I will go ahead and divide by 3. So x is going to be equal to 2 plus the square root of 75 divided by 3. Now, we need to see if this can be simplified. So is there a perfect square that goes into 75? Sure, 25. So if I go x equal to, oh, and remember it's plus and minus, plus or minus, and then this is going to give me 5 times the square root, 25 times 3 over 3. Let's see how I simplified that. I skipped a step, but I took the 25 out, took the square root of 25, which gives me 5, and it leaves 3 inside. Now, if this could be simplified some more, meaning if you could factor a 3 out of the numerator, there'd be a 3 in the denominator, or if you could factor anything that's a multiple of 3 out of the numerator, you could reduce this. Now, let me tell you one thing that you can't do is like you can't divide this 3 by this 3. Also, if you had like a 3 there, you cannot go 3 goes into 3. You have to be able to factor the 3 out of both terms. You can't just cancel a term here or cancel a term here. You have to factor it out and then cancel the factored 3 out with this 3, if that were possible to do. In this case, that doesn't apply. Okay, and that is using the square root property. Method is finding or completing the square. Now, this is a method that I don't use to solve a quadratic equation. Some people might. It will always work, but the process of completing the square is used in other parts of this class and in all the other math classes. As you go forward, you'll be completing the square in calculus and also later in this class. So we have to learn how to do it. I don't really care if you use it to solve a quadratic, but the method is, well, you get it set equal to 0, and then divide both sides by whatever the leading coefficient is to make the leading coefficient 1. And then we want to isolate the variable terms on one side of the equation. These are the variable terms. And so that means we want to have the C on the other side. So it'll look like this. We'll divide out the A. Let's just write it like this. And then it'll equal minus C over A. If I subtract C from both sides, and that's an A. Sometimes my A's look like 9s. So then it's going to look like this. And then what you're going to do is what's called completing the square. So you add the sum of 1/2 of whatever this middle coefficient is going to be, the B over A. So you actually divide that by 2, and then you add it to both sides. And then you factor, and it's going to be a perfect square trinomial. Because see what you're doing here, you're completed the square. So what it means, what you're actually doing is, if this is not a perfect square trinomial, you're figuring out what to add to this number to make sure it is a perfect square trinomial, or that this will be a perfect square trinomial. And then you have to also add to the other side. So then we apply the square root property and solve for x. So we have to use the square root property here, but we're getting this into a form where it factors into, it'll factor into the form u squared equals p, whatever. Okay, so let's do an example. It sounds kind of crazy when you just hear the steps. It makes more sense, I think, when you do it. So let's see. Okay, so what I'm going to do is, in this case, and I could just go ahead, let's just go ahead and make this a 0. Or why don't we write it? I'm more used to writing it in this order, although it doesn't matter, but I'm just kind of used to writing it in this order. And go ahead and set it equal to 0. So we want it set equal to 0, and we want it in this form to begin with. Now, the leading coefficient here is 1. So, dividing out of 1 is not going to do anything. So, you can write the leading coefficient here. Probably won't hurt. Might come up somewhere else. And then we've just got the -9 equals 0. Now, then what I'm going to do is I'm going to complete the square. I'm going to figure out what to add to both sides to make this a perfect square trinomial. The way you do it is you take the middle coefficient and you divide it by 2 and you square it. Okay, so that's going to be -3 squared, which is going to be 9. Then what you do is you're going to go x squared minus 6x, and you're adding a 9 right here. And then what's going to happen here, and actually I'm not adding, the way they say to do it, you could put the 9 on the other side. I think I'm just going to go ahead and do that. Let's just go ahead up here and put the 9 on the other side. We're going to have to put it over there eventually anyways. Add 9 to both sides. Okay, so what we've done though, we've got to add this 9 to both sides. Oh, I'm so sorry, guys. I'm so sorry. So let's look at what we did. I know you couldn't see it. So what I did was I put the 9 on the other side, and then I take half of this coefficient, divide it by 2, and square it. This is the number that we add to both sides to complete the square. Okay, so I'm adding it to both sides. There was already a 9 there. The number to add to both sides is 9. And so then this is going to factor into x minus 3 squared. And then that's equal to 18. Okay, so what we're doing here where it says solve, we're find the zeros is what we're doing again. So that's what we've got now. Now, how do I know this is going to factor into this? Well, because we completed the square, but if you look at this, the number that we added here was a -3. So a -3 is going to go there. And you can check it. You can always check factoring by multiplying. Multiplying the factors back together. So this will give me x squared minus 3x plus 9. That gives me x squared minus 6x plus 9. So we're checking the factoring. So that's right. So this is going to factor. Now what we're going to use is the square root property. Because basically what we've done is we put this into the form where we can use the square root property. So I'm going to go x minus 3 equals plus or minus the square root of 18. Kind of running out of room here, ladies and gentlemen. So let me see. Take another piece of paper. Okay. This is the back of a piece of paper. So I'm going to get x equals 3 plus or minus the square root of 18. I get x equals 3. We've already, simplified this once before. Square root of 18. X equals 3 plus or minus, and if you take the square root of 9, that's going to be 3 times the square root of 2. Now, if you wanted to, you could factor that 3 out, but it's not necessary. Let's do 3. Now, how do you check this? Well, I mean, you can check it on your calculator. If you go back to the original equation was 0 equals x squared minus 6x minus 9. You can actually, on your calculator, just put this in for x and see if it comes out. Just put this number in for x right there, and you can use your calculator and check it. Okay. So let's see what's next. Okay, now the quadratic equation. Gosh, that's an important equation. It's not that hard to derive, but I don't think I derived it here, did I? Anyways, it's not that hard to derive, actually. You have to complete the square, but it's not that hard to derive, but you need to memorize this. And guys, you know, you're not supposed to be using your notes or the book or anything while you're taking a test or a quiz. And if you are, it'll hurt you in the end, because eventually, pretty soon, we're going to be going to iCollege and taking quizzes and tests. And then you're going to be videotaped while you're taking your test. And it's going to flag you if you take out something or go to another website or anything. It'll lock you out of the test if you go to another website. But you better be learning these things. You know, make yourself a little study sheet, not a cheat sheet, a study sheet with things like this on it, because you're going to have to memorize this. So now, one thing that they talk about first is this thing under the square root, the b squared minus 4ac. That's called the discriminant. Okay, so that's the discriminant. Well, if this number is negative, well, if there's a negative under the square root, the equation has no real solution, because that's going to be a non-real number. But if it's greater than or equal to 0, you'll have real solutions or a solution, and they're given by this quadratic formula. So, you know, you can check before you even work it out to see if you're going to have a real solution. Okay, so let's look at an example of this. Or maybe we're talking more about the discriminant. Let's look at the discriminant. Okay, so what the discriminant tells us, I didn't finish telling you that. It's called the discriminant of the quadratic equation because its value tells whether the equation has real solutions and how many solutions to expect. The discriminant also tells how many real zeros or x-intercepts the quadratic function will have, which means, you know, the solutions of if you set this equal to 0. Now, this is the way it goes. So the discriminant of a quadratic equation, if it's positive, there are two unequal real solutions. So two different real solutions. Therefore, the graph of f of x equals ax squared plus bx plus c will have two distinct x-intercepts. So it would either go, in a quadratic, it's going to, you know, have this kind of shape. It could be open and down, or it could be open and up, but it's going to cross the x-axis at 2 points. If the discriminant is positive. So if this is if b squared minus 4ac is positive. Now, if it's equal to 0, then there's a repeated real solution, a root of multiplicity 2. And, you know, they talk about stuff before they actually explain what it is. We're going to see what multiplicity 2 is later on, coming up soon. Therefore, the graph of the function will have one x-intercept at which the graph actually touches and not crosses So it'll look like this. It'll either touch there, or it could, be shifted, or it could be going upside down. So, it could be shifted as well. Now, if it's less than 0, there is no real solution. Therefore, the graph of this function will have no x-intercept. So what that means is it's just not going to touch the x-axis. It could be like that, or it could be, it could be like this, or it could be shifted, whatever. So that's the way it goes with the discriminant. So it's good to know what to expect from what the graph is going to look like, and you can tell that some of that from the discriminant, and you can get the x-intercepts. So we'll have 2 if this is positive. If b squared minus 4ac equals 0, then it's just going to have the 1, and this is if b squared minus 4ac is negative. Then it's going to look like one of these. Okay, and then to find the number nature of the zeros of a quadratic function, evaluate the discriminant first. That's not a bad idea because it tells you what to expect. And if the discriminant's negative, you're not going to find the real 0. It's not going to have an x-intercept. So we're going to find the real zeros of the function using the quadratic formula, also determine the discriminant. So let's look at the b squared minus 4ac. Well, first of all, a is equal to 2, because we want it in the form ax squared plus bx plus c. So if it's not already in that form, and this one isn't, now that I look at it, let's go ahead and set it equal to 0. But look, it needs to be, and this is something that tricks people a lot of times. It's easy to make that mistake. It's just not looking carefully, but the x term needs to come second and the constant at the end. And it's going to make a big difference in the quadratic formula if you don't do that, or the discriminant. You're just going to get the wrong answer. So the b here is equal to a 2, and the c is equal to a minus 1. And then this is what you're going to use in the quadratic formula and the discriminant. Okay, so b squared minus 4ac, well, that's going to be 2 squared minus 4 times 2 times minus 1. Now be careful here, because this is going to end up, you're going to add whatever this number is. So you're going to have 4 plus, because you've got 2 minuses, and that's going to be 4 plus 8, which equals 12, which is positive. So I know that this is positive. We're going to have 2 real solutions. Okay, so now that we know we're going to have 2, let's go ahead and solve. So you have to know the formula. And this is one you really should memorize. If you're going on in math, you're going to have to use this over and over. And, you're just going to be expected to know it from now on if you're going on in math. I don't know, in business, you probably need to use it. And also in the sciences. And of course, then you are in the other sciences, you will be taking through calculus. So the formula goes like this. So you're solving for x, it equals minus b plus or minus the square root of the discriminant, b squared minus 4ac, all over 2a. And this is all over 2a. So that fraction bar goes all the way across. I see that mistake a lot too. So then what we're going to have is x equal a minus 2 plus or minus the square root of 2 squared minus 4 times a, which is a 2, times c, which is a negative 1. And I see, oh, and then that's got to be over to times 2, because A is equal to 2. A lot of times I see sign mistakes here. You got a minus and a minus, that's going to become a plus. So you're going to have a minus 2. You're going to have plus or minus 4 plus 8. And we already knew that because we found the discriminant already. And that's going to be over 4. So then x is going to be equal to minus 2 plus or minus the square root of 12 over 4. Now, can 12 be simplified? I mean, can the square root of 12 be simplified? Is 12 divisible by any perfect squares? Well, of course, any number is divisible by 1, and 1 is a perfect square, but that doesn't help us in simplifying. But how about 4? 4 goes into 12, and 4 is a perfect square. So I can simplify this. So let's simplify. This is the answer here, but let's just simplify a little bit. So we're going to have x equal minus 2 plus or minus, and then I'm going to take the square root of 4, which gives me 2. And what's left inside, if I divide out the 4, is a 3. And that's over 4. Now, in this case, we are going to be able to simplify some more. So what I'm going to need to do, and I'm running out of room here. Let me just get a piece of paper to write on here. I'm running out of room here. Oh, wait a minute. I don't take that. Hold on just a second. I need a piece of paper. Here we go. Okay, so I had so much trouble with this. Be a better way. It probably is. I just don't know what it is. Have great technology here. But anyways, I can divide a 2 out of the numerator, and I can either divide a positive 2 or negative 2. It doesn't really matter, but it'll leave me with the negative 1 plus or minus the square root of 3. And then I do have a factor of 2 in the denominator, because 4 is 2 times 2. And that's multiplying right there. Then I can go 2 over 2 is 1. I can take this 2 over 2, and it's just 1. And so then what I get is x equal minus 1 plus or minus the square root of 3 over 2. Now, these are 2 real solutions, because one of them is a minus 1 plus the square root of 3 over 2, and the other one is x equal minus 1 minus the square root of 3 over 2. You could check it if you put these numbers back in the equation, the beginning equation. It will end up being 0. So we've got 2 distinct real solutions, and that means that we've got 2 zeros. That means 2 x-intercepts. Okay, so, and you just use the quadratic formula a lot in math. Sometimes if something looks like it's going to be hard to factor, well, just use the quadratic formula. You don't have to factor everything. So let's look at another example of this. Okay, so we want to solve using the quadratic formula. And I mean, that what we're really trying to do is find the zeros. Okay, so let's just go ahead and set it equal to 0. Make sure it's in standard form. So really, like if you write the steps, set it equal to 0. Standard form, it needs to be in standard form, which goes ax squared plus bx plus c equals 0. And then you use the quadratic formula. So you've got to know the quadratic formula, quadratic. And then you just simplify. Now, one thing that's good about the quadratic formula is it will always work for solving for the real zeros, if there are real zeros. Factoring, like if you look at this will not factor into two binomials. Because if I went 4 times 1, that would give me 4. Can you think of two numbers that give me a product of 4 and a sum of 1? No, this will not factor. So it will not factor. So if it doesn't factor, and of course you're not going to use square root property on one like this, your choices are either to use completing the square or the quadratic formula. I would use the quadratic formula. I don't know, it's just seems easier, but you've got to know the formula. So it goes x equal minus b plus or minus the square root of b squared minus 4ac all over 2a. So you need to know what a and b and c are. It's not a bad idea to write it out. What is a? A is 4. B is equal to 1. And c is equal to 1. Okay, we could first check with the discriminant. The discriminant is the b squared minus 4ac. It's the part underneath the square root. So this is supposed to say D for the discriminant. So D is going to be equal to 1 squared minus 4 times 4 times 1, which is going to give me 1 minus 16, which gives me negative 15, which is less than 0. So I know there's not going to be no real solutions, no zeros, or no real zeros, no x-intercepts. Now, if you didn't think to use the discriminant, well, you can go ahead and put it into the quadratic formula. And if you do it correctly, you're going to end up with a non-real number. So let's just try that. So if we go x equal minus b, so minus 1 plus or minus the square root of 1 squared minus 4 times a, which is 4, times c, which is 1, all over 2 times 4. Well, we know what's going to happen when we simplify this. This is going to give me a negative 15. So I know that it's not going to have any real solutions. No real solutions. No real zeros and no real x-intercept. Now, if I look at this, what did I start out with? 4x squared plus x plus 1. It's going to, I don't know exactly what it's going to look like, but it is not going to cross the x-axis. I know that. That's really the only thing I know. And then down here, it says it for the summary. So finding the zeros or x-intercepts of the graph of a quadratic function. So you want to set the equation equal to 0, and also be sure it's in standard form, which is what that's saying, really. You want it in this form. Identify A, B, and C, and I write it out, you know, like I wrote A equal B equal C equal. Evaluate the discriminant, because this will tell you whether you really need to go any further. If the discriminant is negative, the equation has no real solution, so the function has no real zeros. The graph of the function has no x-intercepts. Okay, if the discriminant is non-negative, greater than or equal to 0, determine whether the left side can be factored. Okay, so yeah, if you can factor it easily, I would recommend that. You know, if it's a hard one to factor, I would probably just go ahead and use the quadratic formula. But if it's easy to factor, no, I didn't make this. Then go ahead and factor it. If you can easily spot factors, use the factoring method to solve the equation. Otherwise, so if it's not easy to factor, use the quadratic formula or completing the square. The solutions to the equation are the real zeros of the function. The solutions or solution are represented or also represent the x-intercept of the graph of the function. And it didn't say anything about the square root property in there, but you know, if in the form x squared equals a squared, use the square root. Okay, now I think we've got a couple of word problems now. Well, no, that's not what we've got first. The next one we have is finding the intersection of two functions. So we do this a lot in calculus. We have to do this. Knowing where two functions are equal to each other will be of interest. For example, if R is the revenue function, so it's the revenue for selling X units of a good, and C is the cost function, so that's how much it costs to manufacture X units of a good, then knowing the number of goods for which the revenue equals the cost might be important. And that's called the break-even point, I think, when the revenue equals the cost. Finding this requires solving the equation Rx equals Cx. If f and g are two functions, each solution to the equation f of x equals g of x has a geometric interpretation. It represents the x coordinate of each point where the graphs of y equal f of x and y equal g of x intersect. And so, like, where's my calculator? Right here. You know, you can see this on your calculator. If I go and I graph these two functions, so let me clear that out. And let's go over to y equal, and let's go 3x squared minus 7. Now that's going to be a quadratic. And it looks like that. And then I also graph this linear one down here. It's 10x plus 1. So let's also graph it. And I'm going to go to the next line. And I'm going to go 10x plus 1. And I hit graph again. You see, they intersect right here. And they're also going to intersect again somewhere up here. Now, your calculator can actually approximate where they intersect, but it might not give you the exact value if the value is not an integer. So what we want to do is set them equal to each other and solve, and we're going to have a quadratic equation. So what I'm going to do is I'm going to set f of x equal g of x. Okay, so 3x squared minus 7 equals 10x plus 1. And then I'm going to get it set equal to 0, and I'm going to solve the equation. So I'm going to subtract 10x from both sides, and I'm going to subtract 1 from both sides. So this is the equation that I have, and it's going to be set equal to 0 now. So I could use quadratic formula on this, or I could factor it, and I'll just factor it to show you how that's done again. So we want to go 3 times a negative 8. And that's going to give me a negative 24. And I want a product of negative 24 and a sum equal to negative 10. So I'm going to have to figure that out. Maybe you can just think of it. Let's see. What can we use? So let's see, what can we use? How about a negative 12 and a 2? Well, I probably have to, maybe you have to go out and write, some of the factors to figure this out. But that'll give me a product of negative 12 and a sum of negative 10. So what we want to do is we want to write it out like this. Now, if you put the negative, if there's only one negative, if you put it first, it will make it less likely that you make a sign error. And then put the positive term here. You can do it the other way, but if you do it the other way, when you go to group, this is what you have to do. You have to change this sign. Because you think about it, if you distributed this, it would give you this. Okay, so this should be the same. This should be the same equation as this. Okay, so let's see. The greatest common factor here is an x. And so that'll be, oh, wait a minute. That's supposed to be an x squared right there. And something is wrong. So you can factor an x out. So I'll have a 3x plus 2. And then I can factor a 4 out here. That's the greatest common factor. So factor a 4 out, and I'll have a 3x plus 2. Because if these are not equal, this is not equal to this, then something's gone wrong. Or it doesn't factor, but that's not going to be the case, I don't think, in your problems. So this is the same. So I factor that out, and it's real important to use your parentheses. And then what I'm left with is an x minus 4 equals 0. So then I have 3x plus 2 equals 0. So 3x equal negative 2, or x equal negative 2/3. And then I have x minus 4 equals 0. So x equal 4. These are the points of intersection of those two graphs. So one of them is at negative 2/3, and one of them is at 4. So we might could zoom in. Let's see what happened. Calculator just turned off for some reason. Okay. Well, you can just see. No, I don't want to do that. I want to go second function, calc. And 1, and if x is equal to, what did I say? Negative 2/3. And then I get this for the y, but I should get the same y for each one, because these are two different functions. And the same thing should happen for the 4, because we got x equal 4. So if we do that, we get 41, and it's the same on both graphs. So that's what we're saying. So we found the intersection. These are the intersection points. Okay, so that's that. And now we have the word Okay, so this is an application problem that has to do with physics. An object is propelled vertically upward with an initial velocity of 20 meters per second. The distance s in meters of the object from the ground after t seconds is given by this equation. So it's s. A lot of times they use s for position or distance equals minus 4.9 t squared plus 20t. Now, you don't have to come up with this equation, but as my calculus students do, but the minus 4.9 is because of gravity and because we're talking meters. That's a constant. So it's negative because gravity is pushing down. And so, you know, an object's going up, it's propelled upward, and it's going to also come back down, isn't it? And this form, it actually forms a quadratic or parabola. And so this is a big application of a quadratic is when throwing something up or shooting something upwards, it's going to come down. So the 20 comes from the initial velocity. So the question is, when will the object be 15 meters above the ground? Well, that's pretty easy. You just set the distance or the position equal to 15. And then what we're going to want to do is we are going to want to get it set equal to 0. So I would need to get it set equal to, oh, wait a minute. Yeah, so I'm going to go 0 equals minus 4.9 t squared plus 20t minus 15. And then what I get is t using the quadratic formula. I'm so sorry. Sometimes I'm not looking at the screen. I'm looking at what I'm writing. So I'm just going to use the quadratic formula. I don't think this is going to really factor very easily or at all. So I'm going to go minus 20 plus or minus the square root. And this ends up being 106 when you use the quadratic formula. So t is going to equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So I use the formula and I end up getting this. And I put that in my calculator and I get t. I don't remember if this was exact or it was approximately. It didn't say what to round to, so maybe this is the exact 3.09 seconds. And you could just say S. So basically what's going to happen, what that means is that it's going up and then it's going to reach 15, what's it be? 15 meters, yeah, 15 meters going up and then coming back down. There's going to be two places, two times when it's at 15 meters. Okay, the next question says, when will it strike the ground? Now, this is an important thing to remember because S of t is the distance above the ground. Above the ground. Go in, above the ground. Of the object. Well, how far above the ground are you going to be, or what is S of t going to be when you hit the ground? So, you know, like this is the ground, and it goes up, and it comes back down, and it's like kind of like the x-intercept, isn't it? The distance is going to be 0. So we have 0 equals, and this was our equation again, Now, you could use a quadratic formula on this, but it would be easier in this case to just factor it because it doesn't have that last term. And we've got the constant term, and we've got t as a common factor. So I can factor a t out. And then I can set both factors equal to 0. So I have t equals 0. So that makes sense. It starts off at the ground. And then I have or t equals, t equals actually, t doesn't equal 0. I need to set this equal to 0. Minus 4.9 t plus 20 equals 0. And that's a minus. So you can go ahead and work that out. It didn't actually work out, but it's t equals 4.086, I believe. So this right here is t equal, and it's almost 4 minutes, or it's about 4 minutes, or 4 seconds. Is it minutes or seconds? Seconds. I should have remembered that. Then the last question says, will the object reach a height of 100 meters? Well, I kind of doubt it, but let's see. How do you actually know? Get another piece of paper to work this out on. Okay, so this is C. And C says, will the object reach a height of 100 meters? Well, we can't just guess, although I would pretty sure it's a no, but let's look at it. So what we would do, the number of meters above the ground is given as 100. So we would go 100 equals minus 4.9 t squared plus 20t. And you get it set equal to 0 like we've been doing. And then when you substitute into the quadratic formula, you'll get t equals minus 20 plus or minus 20 squared minus 4 times minus 4.9 times a minus 100. Because that's 4ac all over 2 times a, which is 2 times negative 4.9. Okay, I can already tell this isn't going to work. Well, let's go ahead. But here I've got 3 negatives, so it's going to end up being negative. So t is going to be equal to negative 20 plus or minus, and then I've got the square root. I didn't write down what it was. What is it? Let's go ahead and figure out what this is going to be. So I'm going to have, let me just figure this out. Second one should fit. I'm going to go 20 squared. That's a 20 there. 20 squared. And I could have just looked at this discriminant without writing all this out. And then it's going to be minus 4 times 4.9. Or actually, I should put a square root there. Hold on just a minute. Clear it again. 20 squared minus 4 times 4.9 times 100. That comes out to be a negative number. So what does that mean? It's 9.8. That means the discriminant is negative. So the answer is no. This is not a real number. No, the object never reaches the height of 100 meters. Okay, so this is a very, very common application for a quadratic. The revenue and cost is it's an application for all kinds of different functions. But anyways, there's one more thing I need to tell you, and it's going to be good night. One more problem I need to do. I need to show you. Okay, a problem may not be a quadratic, but it may be what we call quadratic in form. And if you've got something that's in the form of a quadratic, so u may not be x, it may be something else. Like in this case, because it's a fourth degree, what it is, and so I'm going to go ahead and set it equal to 0. X to the fourth is x squared squared. And then you've got minus 10 times x squared plus 24. So it's in the form of a quadratic, but instead of x, you've got x squared. So let's make a substitution, which is something we do a lot in math. So let u equal x squared. Then what it's going to look like is it's going to be u squared minus 10u plus 24. That's a quadratic. So, and we can factor this. Let's see, we want two numbers whose product is a 24, positive 24, and whose sum is a negative 10. So I think we can use u minus 4 times u minus 6. Let's see. That's supposed to be a u minus 4. That would be u squared minus 6u minus 4u plus 24. That'll work. So then u minus 4 equals 0. U minus 6 equals 0. So u equals 4. And u equals 6. Now, this is important. So many times people stop with that. I can understand why they did it, but we're solving for x. So we're not finished. So u is equal to x squared. So we've got x squared equal 4. And that's a 4. Or x squared equals 6. So then we get x equal plus or minus the square root of 4 is 2, or x equal plus or minus the square root of 6. Now, there's actually 4 solutions. And that's what we would expect. We would expect to be able to account for 4 solutions because it is a 4th degree polynomial. So this is like really reversing the substitution. So you always need to do that. Okay, now that is it for tonight. Okay, that's all, folks. So I'll be back soon with the next section. I hope you have a good evening. Good night.